Good morning, everyone. My name is Tirushan Raj. My matrix card number is 15 DET 23F1050 from class DET 23. My lecturer's name is Tuan Muhammad Mizan bin Abdul Malik. Today I'm going to do semiconductor devices EOC2 presentation. Question A. State the definition of cutoff region, saturation region, breakdown region. Roman 1. The cutoff region is when a transistor acts like an open circuit due to very low base current. In a transistor, the saturation region is when it acts like a closed switch. The collector and emitter become sorted together, allowing maximum current to flow between them. This happens when both the base emitter and base collector junctions are forward biased. Roman 3. It's the region on a graph that shows the relationship between voltage and current where the material starts to conduct much more electricity. This happens when a high voltage is applied in the opposite direction of normal operation, reverse bias. B. Compare the differences between junction field effect transistor JFET and bipolar function transistor BJT in terms of Roman 1 terminal, Roman 2 current flow, Roman 3 current. JFET terminals, gate, drain, source, current flow, unipolar, control, voltage control, BJT, base, collector, emitter, bipolar, current control. C. With the aid of a diagram, write the operation of enhancement mode MOSFET. This is my answer for a diagram. Answers. An enhancement mode MOSFET is a type of field effect transistor where a voltage applied to the gate terminal controls the current flow between the drain and source terminals. Unlike the depletion mode MOSFETs, which conduct current with zero gate voltage, enhancement mode MOSFET require a specific gate voltage called the threshold voltage VTH to turn on and conduct current. Here's a breakdown of the operation based on the voltage applied to the gate. VGS smaller than VTH, threshold voltage. In this region, the gate voltage is not high enough to create a conductive channel between the drain and source. The depletion region around the gate prevents current flow and the MOSFET acts like a open circuit. VGS equals to VTH. At the threshold voltage, a thin inversion layer conductive channels start to form between the drain and source, allowing a small amount of current to flow. This is the turning point where the MOSFET begins to conduct. VGS greater than VTH. As the gate voltage increases above the threshold voltage, the inversion layer becomes thicker and more conductive. This allows more current to flow between the drain and source. The MOSFET operates in the triode region where the drain current increases proportionally with the drain source voltage VDS. Pinch off. When VDS reaches a certain voltage, the channel near the drain starts to narrow due to the pinch off effect. This limits the increase in drain current and the MOSFET enters the saturation region. In this region, the drain current is mainly dependent on the gate source voltage VGS and relatively independent of the drain source voltage VDS. Key points: enhancement mode. MOSFET require a positive gate source voltage to turn on for N channel or a negative gate source voltage to turn on for P channel. The threshold voltage VTH determines the gate voltage required to turn on the MOSFET. The MOSFET operates in three regions: cutoff, triode, and saturation. Question 2. State 3 applications of DIAC. Answers: lamp dimmers, heat controls, and motor speed. B. Explain four methods to turn on the SCR. Answer: by cutting the circuit passage current SCR. For an example, is by putting the appliance at any current passage, started the anode and cathode, shutting down the positive voltage supply at anode by changing the poles of voltage to anode to become negative. Draw and label the UJT characteristics curve with cut-off region, saturation region, negative resistance region, peak point, and valley point. This is the diagram for my answer C. Cut-off region, negative resistance region, saturation region, and peak point and valley point. That's all for now. Thanks for watching.